Okay, year 11, I'm going to go over some of the work or go through exercise 407 now. So in 407, we're going to talk about parallel and perpendicular lines. And the only new thing that you're going to learn here is to find the gradient of parallel and perpendicular lines and hence find the equations of parallel and perpendicular lines. And the first thing we need to understand is that if two lines are parallel, well then they're got the same slope because they are parallel. Now, if they have the same slope, it means that they have the same gradient. And there's your first bit. If two lines are parallel, M1 equals M2. And you need to write that. If two lines are parallel, then they have the same gradient. M1 equals M2. If two lines are perpendicular, all right, perpendicular means that they meet at 90 degrees. So if I have a line like this, and I have a line like this, the gradient of this line, let's call it M1, and the gradient of this line, M2, they will meet and their gradients multiplied together, because they're perpendicular, their gradients multiplied together equals -1. Which means if you write an equation for that, M1 times M2 equals -1. Well, to get one gradient in terms of the other, you just divide that M2 across, and therefore, if two lines are perpendicular, their gradients are the negative reciprocal of each other. Now that sounds difficult, but it's quite easy, because all you need to do is turn it upside down and change the sign, and you'll have the gradient of the perpendicular. So how do we apply that? Let's go down here to 407, and they're asking you to find the gradient of the straight line. All you got to do is find the gradient, and they're going to be parallel and perpendicular. So I'll do a couple of these. So here we go. Here's the first one, and we've got y equals 3x. So 3x, so here's 1a, and 3x, oh goodness me, let's get rid of that for a start. 1a, and 3x plus y minus 4 equals 0. All right, so I need to get that in gradient form. So I'm going to take the 3x over the other side, so minus 3x. I'm not even really worried about the 4, but I'll do it properly anyway. I'll take over the 4. And there's the gradient of that line. So therefore, if M1 equals -3, well then M2 is parallel. It also equals -3. Okay, let's have a go at B. Perpendicular to that line. Well, that line is exactly the same. So therefore, the perpendicular gradient, and let's use another one, M3, is a negative reciprocal. So change the sign and turn it upside down, or turn it upside down and change the sign. So perpendicular, the gradient is a third. If they've given you 2 points, remember, that method's quite easy. Write your 2 points above one another, 3, 5, -1, 2. And what you need to do is to calculate the gradient, M1. You subtract the y's, so 5 minus 2, making sure you keep them in order, and 3 minus -1. Well, that'll give you 3, 5 minus 2 is 3, on 4. So the gradient of the line that goes through those 2 points is 3 on 4. Therefore, the gradient of the line parallel is also going to be 3 on 4. If you wanted the perpendicular, and I know it doesn't ask for it, but I'm going to write it, M3, you turn it upside down, 4 on 3, and change the sign. It didn't ask for that, but that's okay. The only other hard one there will be this inclination, perpendicular with an inclination of 135. So the other ones there you should be right with, but E, so if I do E, and I need to find perpendicular. Now, if the line's going at 135, that means it's coming down there, and that angle is 135 degrees. Now, to find that, I can use my calculator, which I don't have up. Hold on, I'll just get it up, because it's important that you do this. So it's in the downloads. I'm pretty sure. No, it's not there. Oh, there it is. Oh no, that's a setup. I don't want that. There it is. So with your calculator, if you go tan 135, you get -1. So all I do, M1 equals tan 135. Oh, that's ugly. And I get -1. I'm looking for the perpendicular. The perpendicular gradient, turn it upside down. Well, if I turn one upside down, it's just 1, and change the sign. So the gradient is +1. All right, so finding the gradient. Now, how to find the gradient of a straight line that is passing through a point in parallel? This is so easy, and you use your formula, y minus y1 equals m outside of x minus x1. And you need to, this formula is one of the most useful formulas for linear functions. So let's go through the first one. So here we go, 2a. Oh, goodness me. 2a. Passing through 2, 3 and parallel to that line. Well, if it's parallel, it's got the same gradient. So M1, and the gradient is whatever, it's written in intercept form, gradient intercept form, and the gradient of this is the number in front of that, and that's a 1. So the gradient is 1, and it goes through 2, 3. This is so easy. So parallel, I'll just write M2 so we know that we're talking about M2 equals 1. Therefore, y minus y1, so the y value is 3, equals m, and our gradient is 1, x minus the x value, and that's 2. And then I just get y minus 3 equals, and I've got to multiply this 1 through, but it's not going to change anything, so I'm just going to get x minus 2. And I take the 3 over. If I want it in intercept form, now in what Margaret does, she writes it in general form. So I'm going to write it in general form, but it would be better just to go y equals x, so I add that over, plus 1. But they want it in general form, so I need all of these things, this y to come over to the other side. So I just need to move that y over. So I minus it, and I get 0 equals x minus y plus 1. And that's the general form. Let's have a look at the next one, because it's going to be a perpendicular line. And I'll create a bit of space here. I'm going to leave that formula because you're going to use it so much, so we can see it there. So let's have a look at 2b. Oh no, we'll go to a perpendicular one. So I'm going to go down here to here. So 2d. If it's perpendicular, okay, so y equals 2x. So m equals the thing in front of the x, it's written in gradient form, m1 equals 2. The perpendicular, m2, turn it upside down, a half, and change the sign. And what's the coordinates? The coordinates of the point are 3 and -4. So I need y minus the y value, -4, so -4, equals -1/2 x minus the x value, 3. Okay, just tidy that up. Y plus 4 equals -1/2 x minus 3. Now, here's where you've got to be smart. I'm going to take that 2, I'm going to multiply it across here by those two. I'm going to take that -1 and I'm going to multiply it by these two. So let's do the 2 times that. I get 2y plus 8 equals -1 times x, -x, -1 times -3 plus 3. And then I want to write it in general form. Now, when I write it in general form, the x must be positive. So I'm going to bring those two terms over to the left-hand side. So I'm bringing them over. So I'm going to get positive x. The 2y is already positive. Plus 2y. I'm going to minus 3. I've already got 8 there. So minus 3, give me plus 5. And that should be the general form. And I'm just checking my answers. And what are we doing? 2d, x plus 2y plus 5. Now, all of those are going to be very similar. As soon as you find the gradient, you just use your gradient formula. This one here, your point gradient formula. And it's so easy. I will do one more. I'll do k, but you should be right. You should go and have a go at yourself. So here's 2k. And what do we got? 3x plus 2y minus 1. 3x plus 2y minus 1 equals 0. It's going through minus 2 and 4, or -2 and 4, -2, 4. I'm pretty sure we want perpendicular. Perpendicular. So, first of all, let's write this equation in the gradient form. So 2y equals, I'll take the 3x over and I'll take the 1 over. So it becomes minus 3x plus 1. Then I'll divide by the 2. I get minus 3 on 2, x plus a half. Now you'll notice that I left it as 3 on 2. I didn't write it as 1.5 because the gradient therefore is minus 3 on 2. But I need the perpendicular gradient. So m2, which is perpendicular, turn it upside down and change the sign. So now I just use this. Y minus the y value, 4, equals 2 on 3, x minus the x value, -2, minus -2. So I'm going to have y minus 4 equals 2/3 x plus 2. And again, I'm going to multiply this 3 over here into those two terms. And I'm going to multiply the 2 in here. So I'm going to get 3y minus 12 equals 2x plus 4. Now we want it in general term, and remember general form, is wherever the x is positive. So we're going to bring everything over to this side on the right-hand side. So I'm going to get 0. The 2x is already positive. I'm going to minus the 3y, and I'm going to add that 12, so I'm going to get 16. And there we go. So that's the point gradient formula. Now these are just versions of these. To show that lines are parallel or perpendicular, all you've got to do is show that the gradients are equal or the gradients are multiplied by each other to give -1. So I'll quickly do 5 and 6. So 5. Show that those two lines are parallel. Well, what have I got? 6x minus 5y plus 1 equals 0. Write it as y equals. So I'm going to take that 5y over the other side. 6x plus 1 equals 5y. I'm going to divide by 5. 6 over 5x plus a fifth equals y. Therefore, m1 equals 6 on 5. Let's take the other one, which is 6x minus 5y minus 3. 6x minus 5y minus 3 equals 0. Now straight away I actually already know these are perpendicular because they've got exactly the same coefficients in the x and y. It doesn't matter what you add or subtract, because what will happen is when you rewrite that, that's going to get there. But let's show it anyway. So again, we're going to take the 5y over the other side, and it becomes positive 5y. And I'm going to divide by the 5, so I get 6 on 5, x minus 3 on 5. So straight away, you know these are the same lines, although their y-intercept is 2/5 apart. Therefore, m2 equals 6 on 5. Thus, the lines are parallel. So let's have a look at 6. We have to show perpendicular. So perpendicular, show those lines are perpendicular. 7x plus 3y plus 2. 7x plus 3y plus 2 equals 0. And, come on. 3x minus 7y equals 0. 3x minus 7y equals 0. Now I already know these two lines are perpendicular because if I look at the coefficients of each of them, they're opposite and one has a different sign. So I know that, but I'm going to go through the proof anyway, or the show. So I need the y to be positive, so I'm going to take the 7x over the other side. I'm going to get 3y equals negative 7x minus 2, and I'm going to divide by the 3. So negative 7 on 3x minus 2/3. Therefore, m1 is negative 7 on 3. I'm going to do the same here, but here my 7y is positive, so I'm taking it over the other side. I'm going to get 3x equals 7y. I'm going to divide by the 7. 3 on 7, x equals y. Therefore, m2 equals 3 on 7. Now, even though we can say, oh, they're negative reciprocal, hence they're perpendicular, this is the way you should write it. m1 times m2 equals negative 7 on 3 times 3 on 7, which equals negative 1. Thus, m1 is perpendicular to m2. Because that's a rule. The gradients have got to multiply by each other to equal negative 1. So with the rest of those questions, you're just doing that. I think you'll have show that the line passed through the point is parallel. That's right, you just get the two gradients of those two, show they're the same. Vertices of a parallelogram, find the equation of a straight line through that. Look, I'm going to do 7 and 11 to finish. I want you to go and have a go at it. If you're having trouble, come back and see how I do 7 and 11. So I'm just going to create some space here again to rub this out so I can do question 7. Now, question 7 says it's got another variable in there. It's got a k. Okay. Which is not a big deal. Don't get stressed by these. So, 7. 3x minus 2y plus 5 equals 0. Well, let's find the gradient to this. So I'll take the 2y over the other side. 3x plus 5 equals 2y. I'm going to divide by the 2. 3 on 2, x plus 5 on 2 equals y. Therefore, the gradient to this line, m1, is 3 on 2. Now, if I need the gradient that's going to be perpendicular, therefore, perpendicular m2 must be the same thing, but with a change of signs. The reciprocal change of sign. So negative 2 on 3. Now, the other equation is y equals kx. Therefore, thus, can't keep using therefore, k must equal negative 2 on 3. I'm just going to check 7, make sure I'm right. I'm pretty sure I am. That's right, they're negative 2 on 3. Question 11. Now, it gives you 3 points. 3 points. And says, find the equation through that point. So that's the point you're eventually going to use that's perpendicular to the line joining those points. You do not need to find the equation of that line. You just need to find the gradient. So in question 11, I'm just going to write those 2 points, 2 and negative 1, and negative 5 and negative 7. And I'm going to find the gradient. So m1, subtract the y values, negative 1 minus negative 7, over 2 minus negative 5. Well, negative 1 minus negative 7, that's going to be... I do it on my calculator. I would do this whole thing on my calculator. Well, let's do it then. So what have we got? Let's set up a fraction and use a negative sign, negative 1 minus negative 7, and go downstairs, and we get 2 minus negative 5. 6 on 7. Let's double check that in our head. So negative 1 plus 7 is 6. 2 minus 5 is plus. Beautiful. Now, we need the line that's perpendicular. Therefore, m2, which is perpendicular, equals the negative reciprocal. So negative 7 on 6. And we're going through the point 6, negative 3. And we just use our formula. Y minus the y value. The y value is here. So y minus negative 3 equals negative 7 on 6 x minus the x value, which is 6, y plus 3 equals negative 7 on 6 x minus 6. Now you decide where that negative goes. So I'm going to multiply these two by negative 6. I'll multiply them by 6, and I'll multiply these two by negative 7. It doesn't matter. You could do the negative 6 onto the other side. It does not matter. So I'm going to get 6 times y, 6y, plus 6 times 3, 18. Negative 7 times x, negative 7x. Negative 7 times negative 6 is plus 42. Bring it all over so that the x is positive. So I'm going to move all of this over to the left-hand side. So I'm going to get 7x. The 6y is already positive. And I'm going to get minus 42. Well, I better do that in my calculator. I don't want to make a simple mistake. 18 minus 42, negative 24. So minus 24 equals 0. And let's check. Now, hopefully you did that on your own and you came back. 7x plus 6y minus 24 is 0. So that's exercise 407. Make sure you get 408 done before our Zoom meeting.